Hello, welcome back to Summit Tutoring. I'm Ajay S, and today we'll be discussing the heart of algebra. So, in the SAT, there's a bunch of different things that they go over. This would include Heart of Algebra, Passport of Advanced Math, Problem Solving, and Data Analytics. And now they also add 10%, which could be some of the more difficult problems, and that would consist of geometry and basic trigonometry and complex numbers. So that's like I and whatnot. So imaginary numbers. We'll be going over graphing linear equations, interpreting linear functions, and linear inequalities. We'll also be going over linear equations, systems of linear equations, and linear word problems. If you're having trouble with one of these, I encourage you to click on one of the separate videos we have going over those particular questions. We'll go over more examples. The first question of graphing linear equations. So let's read the question. The graph of line K is shown on the x and y plane above. Which of the following equations of the line that is perpendicular to line K? So let's highlight perpendicular. What do we need to solve for when we're trying to find the perpendicular? We need to find the negative inverse. Right? How can we do that? First, we need to find the slope of this equation. Slope is rise over run, so let's do it. It goes down -2, right? And moves to the side 1. So we get -2 slope. X here to the y. This is the equation. Now when solving for negative inverses, I like to flip the x here, -2y. So now we need to isolate the y. So we divide by -2 on both sides, right? So then we have y equals -1/2 x. But now we also need to remember that it's a negative inverse. So we're just going to multiply this by -1. And we will get 1/2 x y. And so that will look like this. Something along these lines. Right? And let's see, which one of these has a slope of 1/2? Oh, right here. C. Alright, let's go to the next one. Interpreting linear functions. A voter registration drive was held in town Y. The number of voters V registered T days after the drive began can be estimated by the equation of V equals 3,450 plus 65T. What's the best interpretation of the number 65 in the context? So let's look. Let's write down the equation. Okay. One thing I want to remind you guys about is y equals mx plus b. That is the formula. This is the linear equation. So they're trying to test us if we understand what all of this means. So this is definitely the constant right here, for sure. Right? And that is the b value here, constant. So that value doesn't change. And I do believe that's how many voters were already registered beforehand. And this V is the value of how many registered voters there are after the drive. So T days after the drive. Okay. So we need to find out what the 65 means. So if this was the constant or the number before the drive, right? and this was after, this is going to have to be the difference. So let's go through the answers. The number of registered voters at the beginning of the registration drive. We know that's not true because that's the 3,450. The number of registered voters at the end of the registration drive. Not really, because that's the V. Cross that out. The total number of voters registered during the drive. I don't believe that to be true, because T is always changing. So the 65 could increase or decrease, and that's what this M is, right? That's the number, or the 65 in this scenario, and X is the variable. So this is the multiplier, per se. So we know C is incorrect. And we know D is correct. So that means 65 voters registered each day of the drive. All right, to the next question. To edit a manuscript, Miguel charges $50 for the first 2 hours and $20 per hour. After the first 2 hours, which of the following expresses the amount C in dollars? Miguel charges if it takes him X hours to edit the manuscript, where X is greater than 2. So in other words, let's try to break this question down. So Miguel charges a flat fee of $50 for the first 2 hours. And then he charges an extra $20 after. We need to find an equation to model after the 2 hours. So this $50 is not changing, and I point this back to the very important equation of y equals mx plus b. And we have our b, because that value is never changing. It's the constant. Right. So we could add that 50 plus. So that's the $50 Miguel is going to earn after the 2 hours. And now we need to say, okay, we don't really know how many hours after he's planning on working. So we're going to put in that variable right over here, the x. Right? And then we have an m. What is the m? That's the multiplier. So how much does he earn an hour? 20. Equals C. What is C? Which of the following expresses C in dollars? So that is basically how much he's going to make after the amount of hours that lapse. And let's see which choice that is. Oh, that's C. Very simple. This could be done very easily. These are the type of questions that you want to save time on. All right. This, I would say, is probably the more difficult questions on the exam. These are like the more challenging questions that really help you get that 700. So let's dive right into it. So, this is what we must do. So we have a 3, a 1/2, a minus y, close parentheses, equals 3/5 plus 15y. And the beauty of algebra is that there's many ways to go about this. But I'm going to do it in the way that's most simple for me. I'm going to first distribute that 3 onto both sides. So I'd get 3, 2, minus 3y. And that is from that 3 over there. And now let's, just for simplicity's sake, we're going to write out the other side. Okay. So, a very good thing to do is that you want to move some stuff to one side and other stuff to the other. So I'm going to move the y's over to this side, and I'm going to move the numerical values over to this side. Well, so if we want to take away this negative 3y, let's add 3y on both sides. Right? Because now we could cancel this out. This equals 0. And this equals 18y. So we have 18y plus 3/5 equals 3 over 2. Right? Now, we would want to make the numerators the same over here because that's how we add fractions. So let's do that. 15. And then we'll have 610 equals 18y. So that would equal 9, 10 equals 18y. And I'm going to do a little trick here, and this is something that you're just going to have to use when you practice and practice over and over again linear equations. I'm going to multiply this by 10. And you'll see why I do that. So we would have 90 over 10 equals 180y. So over here is the continuation over here, right? And then what we could do is we could simplify this. We could say y equals 180. 9 equals 180y. And then we could just divide 180 by both sides. And when we simplify this through, we get 120 equals y. Right over here. Like I said, this is one of the more complicated problems you'll see on this exam, but it's always important to know so you could get your highest possible score. Systems of linear equations. This is another one with a lot of reading. Each morning, John jogs 6 miles per hour and rides a bike for 12 miles per hour. His goal is to jog and ride a bike for a total of 9 minutes, at least. Least is very important. Remember that. Of 9 miles. And no more. Very important. No more than 1 hour. If John jogs J miles and rides his bike for B miles, which of the following systems of inequalities can represent John's goal? So he jogs 6 miles per hour and he bikes for 12, right? So for each hour he gets 6 miles of jogging, right? So I think the J represents the jogging. It's over here. And B represents the bike driving over here. And that all must be done in 1 hour. 1 hour time. He could do as much jogging and he could do as much biking as he'd like. The reason it's not these over here or these over here is because we're not really looking for how many miles he could jog or how many miles he could bike. We're looking for how much time would elapse. And these are what these fractions are for. Okay, now we need to look at the second part of the equation. He needs to do at least 9 miles, give or take, right? So at least 9 or more, he says, right? At least. So that means he could do more if he would like to. So we need to look at these inequalities. This one highlights that he could do more, right? So we know this part checks off. Let's look at this one down here. That means he could do either less or equal to 9. So we know that's not right. And over here we know. And yeah. Right? So J represents the amount of miles he jogs, and B represents the amount of miles he jogs. So let's say he did 3 miles, right? 3 over 1/2, right? Because he jogs 3 miles, and then he biked. Let's say he biked 6 miles. That takes about the same amount of time. And if we simplify these two, we get 1/2 plus 1/2 equals 1. So he would be fine, right? And then he jogged 3 and biked 6 and he got 9. So it would be perfect. So that's how we know A is the right answer. These are ones that I would totally recommend practicing over and over until you really nail this down. These are really easy questions once you get the hang of it. All right, systems of linear equations. These are more of the tricky ones, at least in my opinion. And wording is very important, especially with SAT. So let's read. In a system of equations above, A and B are constants. If the system has infinitely many solutions, what's the value of A? So the reason they could have infinitely amount of solutions is if they were the same equations. So let's do that. How can we get from here to here? We could multiply this by -5. We're allowed to do that. If we change something on the left side, we could change something on the right side. We're not affecting any of its values. We're just rewriting it in a different way. So -15s minus 2t equals -5a, right? Then we'll write out the other side. S plus b equals -7. So we're essentially saying that these two equations are equal to one another, right? So if that is true, we could also say -5a is equal to -7. We're allowed to do that. Because if they're equal to one another, these are also equal to one another. So now we need to isolate a because that's the value we're looking for. B is of no importance to us. They just kind of do that to trick you up. So let's do it. A equals 7/5. Remember, double negatives, then you get positives. So this is your answer. All right, another system of linear equations. This one is very important to know. So, let's see how to tackle this. We want to be able to cancel out either the 2y or the 6x. So we could only have one variable, and then we could solve for it, and then plug it back, and then solve for the other variable. So let's see how we'll do this. Let's multiply this by 2. Right? As a matter of fact, let's do it by -2. So we get -2y plus 6x equals -4 over 2y plus 6x equals 3. Now let's add them. Oh, what? What do we get here? Does -1 equal 0? No. What does that mean? Well, it means that this equation has no solutions. Wait, what? How? It's a good question. So let's write this out. Going back from here, we're just going to take away, we're going to multiply this by -1, right? And we have 2y plus 6x equals 3 on this one. And then we're going to move the 3 to the other side, just so you could have a better understanding of what this means. And then over here, we'll do the same. So we have two of the same slopes, but our y-intercepts are different. And because we're working with linear equations, they will never cross paths. They are parallel. These are parallel equations. So it's 0. Usually they'll have a solution, but you really need to make sure. That's why it's always important to check using simplification. All right, on to the next one. Martha bought a pair of pants and a briefcase at the department store. The sum of the prices, so this sum means addition, right? Of the prices of pants and the briefcases before the sales tax was $130. There was no sales tax on the pants and a 9% sales tax on the briefcase. The total Martha paid, including the sales tax, was $136.75. What was the price in dollars for the pants? Okay, so they have sales tax on their briefcase, but not the pants. So let's find the difference, right? Because this was the total without any sales tax. So we'll just calculate to find the tax on the briefcase. 6.75 minus 130. All right, $6.75. But wait, there's more. So, how can we set up an equation, a linear equation, to solve this? All right, well, we have 9% sales tax. We know how much that is. So how do we calculate sales tax? Well, let's see. Let's say we have the suitcase, right? So we'll represent that as C. And we multiply that by 0.09. And that equals $6.75. Okay, so now we just need to isolate the C. So let's divide 0.09 on both sides. What do we get? We get $75. So that means the briefcase was $75. And then we have the 130 total, and we minus that by the 75. And we get 55. So that means the price of the pants was $55. All right, simple like that. So these are the things they try to test you on. Can you think of ways for solutions? All right. For the next one, let's see. In 2014, Country X had 783 miles of paved roads. Starting in 2015, the country had been building 8 miles of new road, each year. At this rate, how many miles of paved road will Country X have in 2030? Assume that no paved roads go out of service. All right. So let's see. One thing that we need to see is how many years has passed from 2014 to 2030. So let's do the math. Minus that, and we get 16. All right, so 16 years has passed. So in the start of 2014, there's 783 miles already. So that's our constant. Back to the y equals mx plus b, guys. You don't want to forget that. All right. So what is our multiplier? What is our change? It's 8 miles per year. So we write 8x, because that's 8 miles per year. And this is how many years there are, the x value. So that's what this x represents. Time in years, t in years. Okay, so we have 16 years, so 8 times 16, 78, 783 will give us our value. And then we'll get 911. 911, guys. 911. Alright, guys. I hope today's review of the Heart of Algebra was helpful for preparing for the SAT. If you have any questions, please leave a comment below. If you'd like to reach out to any of us personally, you could join our Discord and message one of our tutors. Remember to hit that like button and subscribe button, and turn on post notifications for upcoming videos. We'll see you in the next video.